while you finish your lunch. So I'm speaking at a maths conference, which is very exciting and really inappropriate. Now here's my theorem. Okay, now I don't know if any of you already worked with it, so I've simplified it as much as I can. And it's basically Pythagoras plus Athanasius Kircher squared equals JH, which is Jimi, Hendrix. But actually it's also pi s. The s is also floated out from maths, because you guys use the word math, and I'm sorry, it's not right. I mean, you're speaking English. Thank you. Good. Now I've alienated the whole audience, I apologise. Anyway, what I'd like to talk to you a little bit about is, I'll call it string theory. And Pythagoras, as many of you know, experimented with strings. And in fact, I've got a photograph of Pythagoras, his first gig here. It didn't go very well, actually. It was a complete unmitigated disaster. I mean, PA hadn't been invented yet. He was very pissed off because they spelled his name wrong on the poster as well. And actually, if you've ever heard a recording of him playing, this would be a hexachord probably, because it's 6 monochords joined together. I think it probably sounded something like this, is his first concert. It's probably that, which is a start. And actually was the start of something very exciting, because actually Pythagoras was one of the people who advanced, if you like, the theory, the science of how strings vibrate. And also the difference between pitches. So here you can see these are, I'm telling you stuff you know, but for a reason. This is a string in vibration on the left here, and as you can see it's got a number of nodes there. And the nodes are the points at which the string will stop. That's kind of, I suppose, a molecular version of it. I don't know what I'm talking about, to be quite honest with you. But I can play you what I'm talking about. So that diagram just there is a harmonic, which is actually this point on a string here. It's in all those places. So it means you've got 1, 2, 3, 4 waves and 3 nodes going on the string. It's very interesting. Well, it is quite interesting because obviously Pythagoras there was dealing with struck strings. And as we know, strings that probably didn't sound too good because they weren't bowed. But these days we can deal with bowed strings. This cello is a relatively modern invention. This one's from 1750, so it's pretty much older than America. Sounds most things. I'm really sorry. Independence thing, it's going really well, isn't it? Anyway, the harmonics are strange. It took me about 15 years of playing the cello to realise that actually the harmonics that are on the string, I'll play the notes for you, they sound like this. So that's your fundamental, that's your basic point. That's the first harmonic, the first note, second That's 1, 2, 1. Should be really hard playing standing up, but I'll try and keep going. If there are any dogs in the room, this will start to hurt from here. This is really hard. My legs hurt. Oh, and they go further and further. So you get the ones that start to sound out of tune to areas up to here. Now, obviously, I'm going the string that way, but the string's obviously symmetrical. They work both ways. It's kind of quite cool. And harmonics nodes are fundamentally lazy. If I play a string like that, and I decide to play the first harmonic, that's halfway down the string, it'll sound like that. The string, because it has a sort of memory, and I don't know the reason for this, so forgive me, but if I take my finger away and stop making that note, it carries on. Strings are lazy, which is really odd. And the thing about harmonics is, particularly on the string instrument, obviously when you're hearing that note, you're hearing loads of harmonics overtones all at the same time. You know this. I didn't know this for a long time. But obviously that's the reason for timbre. If I play near the bridge, it's more upper partials, which means it's more of a cutting sound, it hit the back of the room. If I play near the fingerboard, it's more of a kind of fluty sound, rather than a kind of reedy sound. That's just the balance of the harmonics. That's all fine. Now, I want to talk a little bit more about what that means and why it's useful. But before that, I want to introduce the other parts of my equation. This is Mr. Kircher, who is an extraordinary man, polymath. I'm sure you've heard of him. This is his passport photo. He had a way cooler set of instruments than Pythagoras. For instance, his guitar looked like this. I mean, it was fancy pants guitar, I think we can say. 17 strings going on in this, so over-engineered. But also, he had this, which was, it kind of upped the ante a bit. This is his kind of organ for generating music of the spheres. So there's a connection with Pythagoras, because obviously Pythagoras is obsessed with that too. And this is actually an organ. It's like the design for an organ where everything's got a kind of universal harmony, so you can play the trees and the plants. And actually it's quite strange. You can see the tuning, if you look very carefully, it's not got a normal piano keyboard. And in fact, this worked really well, this invention, until the Medicis sold out to Apple, and then it didn't really work after that. This is a kind of prototype laptop music computer. It really is. Everything on the front panel of that box is actually a different kind of mode, a different scale, and then you select your instrumentation from around the edge. And then the amazing thing is that each one of these blocks actually slots in and out. This is a proper design. This is his kind of universal knowledge box / computer. It didn't have any electricity, so it didn't work very well. But all of these are different sort of permutations of phrases, and they do work. And what I like about this is when I first saw this, I kind of thought, oh, what if I was to combine what I know of string technique, if you like, cross-section that with what little I know of science? Maybe I can make some new noises. So that's kind of what I want to talk about today. He also invented this absolutely fantastic design for distributing, well, actually for freaking out your house guests. So there's a mugging happening down on the street on the left, and then the music goes up through a kind of ever-diminishing helix. That's not the right term, I know, so apologies. Up to the mouth of that statue, where a house guest is looking at it, and suddenly this riot comes out of its mouth. And it's actually a system that was, I believe, introduced in certain palaces, where you'd have one bunch of musicians playing down in the basement, and then the music would be filtered into different rooms, depending on which kind of flaps you opened up. It's like a kind of prototype Samos system. He also was responsible for documenting one of the first viral cat videos. This is true. This is true. I don't know if you remember the Muppets. The Muppets was a very important part of my music education, but they had the Muppet phone. This is honestly the cat phone. And I'm glad to say it didn't get beyond this engraving. Because the idea was when you press the key down very daintily, it pulled the cat's tails until they screamed their note. It's a kitty phone. How cool is that? Which is rather nice, because obviously, cat gut brings us the neat feedback. So Pythagoras, see, it's all joined together. Almost thought about it. Now, Kircher, he was also one of the first people, quite strangely, to document actually how things in the real world could be represented artistically, which was actually a colossal, if not heretical move at the time. And you'll see here that there's a cockerel. He's noted down his note patterns, which go do-do-do-do, do-do-do-do. He can give you lyrics. It's all absolutely correct. I mean, this is still what birds sing now, which I think is fantastic. So I want to show you, actually, on a cello, by mucking around with the harmonics a bit, you can end up with quite a few. If we take Kircher's idea, let's represent stuff in the real world, but through vibrating strings and notation. I'll show you a few things I used to get in trouble with my teacher for. So obviously you can do bells, that's obvious. That's fine, that's just by plucking notes. You can do swipes, which is just hitting notes and scooting off them. It very neatly leads on to do Space Invaders, which kind of sound like that, which is nice. Also, if you diminish the upper partials, you can then replicate instruments like panpipes. So if I bounce my bow, if I use that cross-section thing and use one technique, which is a bouncing bow technique, I can then mix that with loosening the fundamental and make this kind of noise for a panpipe. That kind of annoying lift music, you know. You can do very stupid things, obviously. Australian outback, you can make the sound kind of didgeridoo. It wasn't long before I realised, actually, that that is obviously quite close to this. The old Doctor Who. But also, you can do quite weird things. I call these ghost tones, and I think I've invented this, where if I trill an interval, which is this, I can then hallucinate a harmonic, a node, a set of notes above it, like this. That top note isn't actually there, because that's 3 notes on one string, which, as you all know, is not possible. So that's very silly. And someone's already mentioned there, yes, if you can pick out partials like that, you can also pick out things that sound this way. I love reverse engineering, and I play electric cello, but actually I prefer doing things like this on the acoustic cello, because if you're Jimi Hendrix and you had a cello, you might do this. I'm not playing any more of that because that's not my anthem. I quite like, I mentioned those weird fourth harmonics. And back to Kircher, he had birds you could do, and I managed to, a few years ago, nail a seagull. That one there, that's a harpoon. I took a photo of that Monaco. I love that harpoon was staying straight at it. It's kind of looking like, I'm not moving. Anyway, it sounded like this. Which is just a diminished Space Invader. So, you see my way of thinking is kind of, if I take the madness of something like that and apply it to physics and maths, which I know nothing about, you can end up with these weird permutations and combinations. And I think my idea is you can kind of plunge forwards to go backwards. And I want to finish by playing you a piece inspired by what I've heard this morning, which is a Pythagorean caprice. And I thought, what would be great if a Baroque composer worked with Jimi Hendrix. I'm a great one for forwards and backwards collaboration. Like if Handel and Hendrix had lived next to each other, which they did, look at that. That's Handel's house, that's Jimi Hendrix's house in London, in Brook Street. Yeah. That's an album you can download. I'll tell you about that later when I see you over a drink. So here is my Pythagorean caprice for you. I'm making this up, so if this goes wrong, I'm looping it. If this goes wrong, it's your fault, not mine. Okay. Thank you for listening. It's Pythagorean because it's in 6/8, and it's a combination of that in 10 beats. There should be 10 beats in the bar if I'm playing it correctly. My maths is off.